Hello everyone, welcome back to data structure concept. So in today's video we are going to learn the most important data structure used in database and file system, that's a B tree. So we'll understand what is B tree and how it works. So a B tree is a self-balancing multi-way tree. In our previous lecture, you understood what is M-way tree, right? So this is improved version of M-way search tree. So this is not self-balancing, while B tree is a self-balancing M-way search tree, right? So that maintains all the sorted datas and allows efficient searching, insertion, deletion operation, right? All the operation in the logarithm time, right? So it's a generalization of a binary search tree where each node can have more than two children, right? So if we talk about the structure of a B tree, right? So what it contains, so it contains a keys, so that is nothing but the data in sorted order, and child pointer, right? So the pointers are nothing but it is pointing to the child, whether it is left child, right child, or more than one child, right? So this is what we have in a B tree. So if we talk about a structure, so structure will be something the same, like this. P0 is a pointer, K0 it's a key value, P1 again a pointer, K1, then P2, and we can have multiple, right? So this is Pn minus 1, Kn, and Pn, right? So this is a structure, this P0, these are the pointers to the next nodes, right? And it must be in the sorted order, right? So if we talk about that, what are these are the basic structure, but there are some criteria that we need to follow while creating a B tree, right? So what are those criterias, or you can say that's a property of a B tree, right? So let me explain you quickly, right? So that is like every node in your B tree can have at most m children, right? So it's a similar to the M-way tree. In M-way tree also we have the same, right? So every node can have at most m children, right? But there is this is the condition for the maximum, right? We don't have a condition for the minimum in your M-way tree. But here you have that condition that every node except the root node must have at least m by 2 children. So this is another thing that is not available in your M-way tree, right? So in a B tree, the maximum is at most m children and at least m by 2 children, right? Now here the exception is root node, right? So except the root node, all other nodes should have those, right? Then one more thing, as I told you, this is a self-balancing tree, right? So all the leaves, like leaves, must be at the same level, right? So that means it is balanced, right? So this is not available in your M-way tree, right? So tree must be always balanced. So for that you should have this condition that all leaves must be at the same level, right? Then next is keys must be in a sorted order. This is same in M-way tree as well. So sorted data should be there for the keys, and that is also in ascending order, right? And then the last one that is common, that number of keys in each node is one less than its number of children, right? So it's always like if you are having a m children, so key is m minus 1 keys, right, for any node, right? So this is the properties, or you can say criteria, you need to follow while creating uh, binary tree, sorry, b tree, right? B tree and binary tree are different, right? So for creating a b tree you can have this, right? Now you can do search operation in this, right? You can do insertion, you can do deletion, right? If you do the search operation, what you need to do, you need to start at the root, right? You need to compare the keys, right, and follow the child pointer based on that particular key range, right? And that's how you can search. Let me give you a example, right? That suppose if I have something like this. Okay, and here, and here I have, okay, so this is my b tree, right? Now this is of order, like this is of order 3, right? So order 3, that means what? I can have max 3 children, right? And at least 3 by 2, that's a 1.5, and integer is 1, so at least one child, right? So both the condition here, you can say, see that nothing is going beyond 3, right? And the least is also 1 only, right? So that is satisfied. Then so this first one is satisfied, the second one is also satisfied, right? Except the root node, we have exception for the root node. Then leaves must be at the same level. You can see that these are the leaf nodes, right? And leaves are at the same level only, so this is also satisfied. Then the sorted data, you can see 5 6 7 10. So these subtree is having the value lesser than 20. This subtree is having the value that is in between 10 to 20, so 12 and 17 are in between 10 to 20, and this is greater than 20. Yeah, so this one is also satisfied and always have m minus 1 keys. So 3 minus 1, that's 2 keys, right? So here you can say, yeah, that is satisfied over here, right? So this is your b tree, right? Here you need something, here it's a 1 2 and 3, right? So 2 keys are only allowed, right? So what you can do, you need to split it over here, right? So here, what, how you can split it, I'll do one thing, I'll explain the insertion operation in the next video, so I'll explain you with properly, step by step. So here I need to just delete this, right? So yeah, so this is my b tree, right? And b tree is usually like it is mv tree is a very generalized version, right? And this is improved version, this is, that's why it is called the balance mv tree, right? So data are already sorted, and the level are, this is most important thing, that levels are, leaves are at the same level, right? So it's a self balance, right? So self balance, that means you can efficiently search for the data, right? And it is widely used for the file systems like ntfs and hfs, and for the databases also it is very widely used, right? And even the disk storage systems also it is used. So this is like very generalized explanation of what is b tree, right? In the next video lecture, I'll explain you that from the scratch how can we create a b tree, right? So the insertion operation in a b tree, that I'll explain you in the next lecture, right? So I hope you understood the concept of a B tree, right? And how it differs from MV tree, right? So yeah, thank you so much. Thank you for watching this video.